You know, when a life ends, a whole new story begins. But it's a story that's told without a single word, a mystery written in the silent language of the body. So, how in the world do forensic investigators learn to read that story? How do they answer the one question that can make or break a case? When did it happen? I want you to picture a crime scene. Long before any detectives show up, the first witness is already there. And this witness, it doesn't speak, it doesn't see, but it holds the key to absolutely everything. That witness is the body itself. And it has a clock that starts ticking the very moment life stops. Our job today is to figure out how to read that clock. All right, so the first tool investigators reach for is, believe it or not, surprisingly simple: a thermometer. Yep, the body's temperature after death. A process called postmortem cooling, or its scientific name, algor mortis, is really the first chapter in our story. Think of it like a stopwatch that gets triggered at the moment of death. You and I, right now, our bodies are maintaining a steady temperature, right, around 98.6 degrees Fahrenheit. But after death, that internal furnace just shuts off. The body starts to cool down until it matches whatever the temperature is around it. Sounds pretty straightforward, right? Well, not so fast. That stopwatch, it's not exactly perfect. So many things can throw off the timing. Was the body wearing a heavy coat? Well, that's insulation. It's going to slow the cooling way down. Was there a breeze? That's like a fan, speeding things up. A person with a larger body mass is going to hold on to heat longer, while really high humidity can actually slow down cooling by reducing evaporation. Every single one of these variables has to be meticulously calculated. And here's something that might surprise you. It's a really crucial fact. You'd probably think the way someone died would have a huge effect on their cooling rate, but scientifically, it has very, very little impact. And you might be asking, why? Well, it's because once the body's internal thermostat, its whole ability to regulate temperature, shuts down, the environment completely takes over. The surroundings become the real star of the show here. So we've seen how all these little variables can alter the timeline. But what happens if the body is found somewhere that just throws all the standard calculations right out the window? And this brings us to one of the biggest challenges for investigators: a body in water. See, water pulls heat away from a body so fast, so efficiently, that a temperature reading becomes almost useless for figuring out the time of death. Our nice, steady stopwatch suddenly becomes way too fast and erratic to read with any kind of accuracy. Okay, so if temperature isn't always reliable, where do investigators turn next? They start looking for stains, not stains from the crime, but from the body itself. This is where a phenomenon called livor mortis comes in. And believe me, it can reveal a major plot twist. So here's what happens. After the heart stops pumping blood around, gravity just takes over. All that blood starts to pool in whatever part of the body is closest to the ground. This creates a really distinct purplish stain called lividity. It's a grim detail, but it's an incredibly useful physical sign that becomes fixed in place after about 8 to 12 hours. It provides another crucial time marker for the investigation. And this is the truly genius part. If a body is found lying on its back, the lividity, the staining, should be on its back, right? Makes sense. But what if the stains are on the front? Well, that tells investigators one thing, and one thing only. At some point after death, someone moved that body. And just like that, the story has a brand new character. So, as you can see, all these clues kind of have an expiration date. In the first day, day and a half, body temp and lividity are your go-to indicators. But after about 36 hours, their reliability just starts to tank. And once we get past that 72-hour mark, these early witnesses go silent, and a new, very different kind of witness has to take the stand. This is the point where nature itself steps in to provide a new kind of clock. And this clock is often way more precise than any of the others. We're talking about insects. Yep, welcome to the fascinating world of forensic entomology. And look, this isn't just some cool CSI-style idea. It's a hard scientific fact. When all those other early signs have faded away, the insects that arrive at a scene become the single most reliable timekeepers an investigator has. So, why are they so accurate? Well, it's because certain species like blowflies are drawn to a body incredibly quickly after death. And their life cycle, from egg to larva to adult, it all happens on a very predictable, temperature-dependent schedule. It's like clockwork. So, by identifying the species of insect and figuring out what stage of development it's in, scientists can literally count backwards to figure out almost exactly when they first arrived. So, as we've seen, there's no single magic bullet here. There's no one method that solves everything. Instead, investigators rely on a whole toolkit of different methods, and each one has its own strengths, its own weaknesses, and its own specific window of time where it's most useful. Let's just do a quick recap of that toolkit. First, you've got body temperature. Great for the first few hours, but we know it's super variable. Then you've got livor mortis, which is absolutely key for telling us if the scene has been messed with. Another early clue is rigor mortis. That's the temporary stiffening of the muscles, which shows up and then disappears within about 36 hours. And finally, after that 3-day mark, forensic entomology takes the lead as our most accurate clock. The most crucial thing to take away from all this is that the reality is just so much more complex than that 5-second analysis you always see on TV shows. It's not a single, clean calculation. It's an intricate puzzle, with pieces that change their value over time, and every single one is influenced by the environment. It's a story that has to be assembled from dozens of different tiny clues. Which really leaves us with one final thought to chew on. Given all of these variables, the temperature, the water, the possibility of movement, the insects, is an exact time of death ever truly knowable, or is it always just an estimate, a theory, the best possible story that the science of the scene allows us to tell?